Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 5 in the CSRF module, titled CSRF where token is tied to non-session cookie. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the Academy, I'm going to click on Academy. Go down, select the learning path, go down, select cross-site request forgery, and then go down to lab number 5. And we went a little bit too down. So lab number 5 titled CSRF where token is tied to non-session cookie. Alright, let's get started. This lab's email change functionality is vulnerable to CSRF, so the vulnerable parameter over here is the email change functionality. It uses tokens to try to prevent CSRF attacks, but they aren't fully integrated into the site's session handling system, so there's some kind of flaw of how these tokens are integrated, and we'll use that to exploit the CSRF vulnerability. To solve the lab, use your exploit server to host an HTML page that uses a CSRF attack to change the viewer's email address. So the goal of the exploit is to exploit the CSRF vulnerability to change the email address of the victim user. You have 2 accounts on the application that you can use to help design your attack. The credentials are as follows, and we've got the accounts right over here. All right, let's right click and access the lab. And while that opens up, we're going to open up Burp Suite Professional. So just like with the other labs, we'll start off by solving the exercise using Burp Suite Professional, and then we'll script the exploit on our own. So if you don't have the professional version of Burp, make sure to stick around for the second part of the video. All right, hit next, start Burp. That looks good. Next, click on My Account, and then log in with the credentials that we were given. So we're going to assume that this is the victim's account. Hit login. And then the next thing to do is set Foxy Proxy to send requests to Burp. Now, when we change the email address, it should be intercepted in Burp. So click on Update Email Address, and here we go. It got intercepted in the proxy. So I'm going to move that right over here. Send this to repeater, right click and then send to repeater, and then set intercept to off and work from repeater. All right, so we said that if a page is vulnerable to CSRF, it has to satisfy 3 conditions. The first one is you have to have a relevant action, which in this case is the change a user's email action. Now we say that this is relevant because if we had the ability to change it, it would cause detrimental effect to the client or the victim user. So if I could change the email address, then I could use the forgotten password functionality in order to reset the user's account. And since I changed the email address, the reset email is going to be sent to me. And I could use that to change the user's password and fully compromise his account. And so there's definitely detrimental effect to the client if this is possible, which is why we call it a relevant action. So this is satisfied. The next thing to check is cookie-based session handling. You could see over here the application uses a cookie called session in order to perform session handling. And so this is satisfied as well. The last one is no unpredictable request parameters. And this is jumping the gun, so I'm going to remove it and add it later. All right, so you have over here 2 parameters, an email address and a CSRF token. The first one is predictable because it's the email address we want to change to. So the attacker's email address, and so we know that email address up front. However, with the CSRF token, this is unpredictable because we don't know the token value up front. So at first glance, this is not satisfied because we do have an unpredictable parameter called the CSRF parameter. However, depending on how this is implemented in the backend, we might be able to exploit it. So notice over here, instead of having just a CSRF parameter, we also have a CSRF key cookie. And my guess over here is that these 2 are tied together. So the first thing to notice is this is a different value from this. So this is not a case where you have like a double submit cookie. Instead, they seem to be different values, and my guess is that they're tied together. So what happens in the backend is when you get a request, it checks if this CSRF key cookie is tied to the CSRF parameter, and if it is and the values are equivalent to what is in the backend, then the request passes. If it's not equivalent to what is in the backend, then you get an invalid CSRF token message. Now, you usually see something like this if the application is using a different framework in order to manage the session over here, and then another framework to manage the CSRF defense. If this is not tied to this, we might be able to exploit this functionality. However, it would require chaining a couple of vulnerabilities together in order for it to be exploitable. Now, before we do that, we need to test out a few things to make sure that this is something that we can exploit. And so we're going to start off a new section. So in the previous labs, we had testing CSRF tokens. This is no longer relevant because now we don't have just a CSRF token, we have a CSRF token and a CSRF key cookie. So we're going to start a new section called testing CSRF tokens. And CSRF cookies. So the first thing to do is check if the CSRF token is tied to the CSRF cookie. And the way to do that is, let's make this a W, so we give it an invalid CSRF token and see if it still accepts it. And it doesn't. So it's detecting that this is invalid. So that's the first test case that we did, is submit an invalid CSRF token. The next thing we're going to try out is submitting a valid CSRF token, but a token that is taken from another user. So submit a valid CSRF token from another user. So let's return this back to what it was, which was a Z, and let's open an incognito session of Firefox so that we could log into the other user. So new private window, and let's copy this URL over here. Hit enter. And let's move this right over here and log in as Carlos. Now we're going to assume that this is the attacker's account and this is the victim's account. So we're going to get a CSRF token from the attacker's account. And you could do that by inspect element. And this is the CSRF token over here. Let's go back to this and put it right over here. So we're going to call this the CSRF token. And then we're going to go back to burp and put it right over here. So we're checking if this CSRF token is tied to this CSRF key. If it's not, this request should pass through because this is a valid CSRF token and this is a valid CSRF key. So let's hit send, and it says invalid CSRF token, which means that these two are tied together. So the last thing to check is submit valid CSRF token and cookie from another user. So now we've entered a different test case. It's not a sub-test case of test case number 1. So I'm going to call this number 2. And what we're doing is we're checking if the CSRF defense mechanism, which is the cookie and the parameter, is tied to the session handling mechanism. If it's not, that means we should be able to give it a CSRF key and a CSRF parameter from another user, and it should accept it. So let's test that right now using our incognito mode. So we already have the CSRF token. All we need is the cookie. And to do that, we'll click on reload, hit my account, and then cookies. And this is the CSRF key of the attacker. So let's copy that and put it in our notes document. And it was called CSRF key cookie, and paste it over here and then put it in here as well. So again, to reiterate, this is the session of the victim user. However, we're using the CSRF key cookie and the CSRF parameter of the attacker. So let's hit send and see if that works. And it does. So if you follow redirection, you could see that it's a 200 response over here, and the email changed to test.ca. So this is good news. That means that the session handling system and the CSRF defense mechanism are not tied together. So what we need in order to exploit this vulnerability is, one, be able to inject an HTTP cookie called CSRF key and inject our own cookie in there. And then we need to conduct a CSRF attack in order to inject the CSRF parameter. So we've got two conditions that need to be satisfied. So in order to exploit this vulnerability, we need to perform two things. The first one being inject, and let's go a bit up. So inject a CSRF key cookie in the user's session. So this is technically HTTP header injection. And we'll explain that in a bit. And the second condition is that you need to send a CSRF attack to the victim with a known CSRF token. So a known CSRF parameter token. And you need to do that all in one go because you don't want the user to be clicking multiple times in order to change the email. All right, so the first thing is to inject the CSRF key cookie in the user session. So we're going to have to find some kind of HTTP header injection in order to perform this goal. And I call it HTTP header injection because that vulnerability occurs when HTTP headers are dynamically generated based on user input. So depending on how it validates that user input, or if there's no validation to that user input, we might be able to exploit it in order to get the browser to set the CSRF key cookie to one that we own. The second condition is to send a CSRF attack to the victim with a known CSRF token. We've done that in all the previous labs, so it shouldn't be hard. The most difficult thing to do in this lab is to find a place where this is possible in the application. And then the second part is pretty much what we did in all the previous labs. So let's go back to our application and see if there's a location where we could inject HTTP headers. So if we go to home, and you could see over here, there's a search functionality that searches these blogs. Let's search for the word hat. Click on search. Actually, before we do that, notice that the cookies that we currently have are the CSRF key cookie, which handles the CSRF defense functionality. And then you've got the session cookie, which handles the session management. And we don't have any other cookies. Now, when we add the word hat and click on search, it searches for the blogs that have hat in the word. But notice over here, we have a new cookie called the last search term, and it contains the value of our search. So if we go to Burp Suite Professional and look at that functionality in the proxy, so HTTP history, this is where we did the search. And we searched for hat, and notice over here it set a cookie called last search term, and it included the value that we wanted to search on. Now, depending on how this is being validated, we might be able to break out of it and set our own cookie. And the way you do that is you add a new line, and we can't do that through proxy. We're going to have to send it to repeater. So let's add a new line, and that's the URL encoding for it. Or I believe it was a carriage return, one of the two. So it's %0D and then %0A. And then we're going to say set cookie, which sets the cookie. And then we're going to put space CSRF key is equal to the attacker's CSRF key cookie value, which is right over here. We're going to copy that, put it in here, paste it, and see if that works. Hit send. And we get a 200 response. That's a good sign. And notice over here, we've got set cookie, CSRF key, and it's set it to the attacker CSRF key cookie value. So this is satisfied, which is great because this was the hard part. So now all we need to do is construct our CSRF attack, which is really similar to what we did in previous labs. So we're going to go back to the change email functionality, right click, click on engagement tools, and then generate CSRF POC. This is only available in the professional version of Burp. But again, if you don't have the professional version, don't worry. In the second part of the video, we'll script the exploit on our own. So the first thing to do is click on options, include auto submit script, hit regenerate. That's what we did in previous labs. You could see it's an HTML document. It has a form element, and this is where it submits the form. It's a post method, and then you've got the email that you want to change to. So let's say test3@test.ca, and then you've got the CSRF token. We need to change that to the CSRF token of the attacker. So let's copy that over here and put it in here. And then you've got the submit button. And what this does is it automatically submits the form. Now, I don't want it to just submit the form. I want it to first visit this over here. So if we go back, I want it to first make this request over here where it sets the CSRF key cookie value. So instead of having this, we're going to remove it and then add an image element. And we're going to say src is equal to, so the source of the element, that's the URL, is this one over here. So we'll take the host of the application, so the domain of the application, put it in here, add HTTPS, and then we need the rest of the path. Let's copy that and paste it in here. And let's just confirm that this is the cookie value of the attacker, H0, and it is. So HO. Okay, that's perfect. The next thing we want to do is say on error, because this is not really a valid image URL. So on error, I want you to submit the form. So document.forms 0.submit. Okay, that should work. So what it's going to do first is try to load up this image. And when it does try to load up this image, it'll set the CSRF key cookie, and then it'll encounter an error, and it'll submit this form over here performing the CSRF attack. So let's test this out in the browser. Hit copy and go over here. Hopefully it hasn't timed out. Let's just double check that right now. And it didn't. That's good. All right, so hit send and see if it submits, and that did not copy correctly. All right, let's go back and submit it again. And here we go. So it did work. However, we forgot to change the email address. So let's say test3@test.ca, and then test in browser, hit copy. Let's do this again and see if it changes it to test3@test.ca. Okay, perfect. So it did successfully run and exploit the HTTP header injection and the CSRF all in one go and change the email address of the user. Now notice that we don't get a congratulations, you solved the exercise message, and that's because we use the Burp Suite server instead of the Web Security Academy exploit server. So we're going to do that right now. In the body section, remove hello world and just copy your exploit over here. Paste it here, store the exploit, go down, and then deliver the exploit to the victim. And you should see a congratulations, you solved the lab. All right, so we successfully completed the exercise by using Burp Suite Professional. Now let's script it on our own. We no longer need the POC generator, so I'm just going to remove that. And we'll still work with Burp Suite Professional, but we won't use any features that are available in the Professional Edition, and make sure that only the features that we use are available in the Community Edition. So let's save this over here and start scripting our exploit. So the first thing I do is add the HTML element because it is an HTML document. Next, we add the body element and an H1 element. So this is what the user is going to see. Let's say hello world. Let's put that back. And then we're going to add the form element, and action, it's the URL of the form. And we're going to get that from over here. So if we go back, we could get that from the host. Let's copy that. So HTTPS, paste it. And then we need the path as well, which is my account, change email. All right, that looks good. Next, we need to add the method, which is a post method because that's what's being used in the request over here. And then you've got the ID of the form. Let's call it CSRF form. So this could be anything. I'm just using it so that I could reference the form later. And then we need to add the input elements of the form, so the input parameters. And you do that using the input element, and the type is equal to hidden because you don't want the user to see that we're performing a CSRF attack. For the name, you get it from right over here, so it's email and CSRF. So the first one is email, and the value is, let's say, test5 at test.ca. So this is the email of the attacker, and we need to close that off. Next, we've got the second input vector, which is also hidden, and the name is equal to CSRF, and the value is equal to the CSRF parameter of the attacker. So to get that, let's go back to our notes, and we get that from over here. Let's copy that and then paste it in here and close off the input element. Now I'm going to click on send so that it doesn't time out. Perfect, it hasn't timed out yet. All right, let's complete the script. The next thing to do is to perform the HTTP header injection, and we'll do that with the image tag. Now, when we were doing it with Burp Suite Professional, while it was loading the script, you could see that there's a submit button and there's an icon for a not found image. So in this case, I don't want the user to know that I'm performing a CSRF attack. So I'm going to make the image invisible by using the style element and hit display none. So this makes it invisible. And then I'm going to add the source of the image. So this is the URL where we perform the HTTP header injection. Let's copy that from over here. And we forgot the domain, but we'll do that in a bit. So the domain is this over here. Okay, this looks good. And then we need the on error attribute. And we're going to say document dot forms 0 dot submit. Okay, and close off the image element. All right, so what this does is it tries to load up the image by visiting this URL. It gets an error and then it submits the form over here. So we only have one form and this is the first one. So it'll submit this form. We didn't actually need to add an ID because we used a different method than previous labs. What this does is it visits the form over here and then submits it. Now, when we were using the professional version of Burp, we could see the submit button and then the user got redirected to the email change functionality. Again, I don't want the user to know that I'm changing his email address or her email address. And so what I'm going to do is submit this in an iframe so that it's completely invisible to the user. So to do that, we use the iframe element. We say style is equal to display none, because I want the iframe to be invisible. And then the name, let's say, is equal to CSRF iframe. And that looks good. And then we need to add it over here in the form element, telling it that it should be submitted there. And so we add the target to be equal to CSRF iframe. All right, this looks good. So let's save this. The last thing we need to do is host the script on our own server. And to do that, we're going to click on Terminal, New Terminal, and then create a simple Python server on localhost port 5555. Now all we have to do is send the user the phishing link. So let's close this over here. Make sure this hasn't timed out, and it hasn't. That's good. So the phishing link would be http localhost, so 127.0.0.1, and then port 555, and then the name of the script, which is CSRF Lab 05.html. Hit enter, and all the user sees is hello world, so the user doesn't even see the image icon, doesn't see the submit button at all. And what should have happened is in the backend, it should have changed the user's email. So if we go back and see if this got changed, and here we go. It did get changed. So the email address is test5@test.ca, which is the email address that we wanted to change it to. So we successfully completed the exercise by first exploiting the vulnerability using Burp Suite Professional and then scripting our own exploit. In the next lab, we'll look at another faulty implementation of a CSRF defense.